Emails can be a real pain in the ass to develop. Writing the code, testing across devices, uploading into GitHub, making revisions. What if you could have an AI assistant that not only builds email templates from a screenshot, but actually understands your feedback and fixes them in real time? Today, I'm going to show you how to build exactly that using n8n, vector databases, and the power of AI. Here's how it works. You provide an initial screenshot of an email. We convert it into a base64 format string. Then we use a custom API request to OpenAI GPT-4.1, which will then provide us with MJML, which is a responsive email framework designed to simplify and streamline creating complex emails. Then it'll send you a test email and an email asking for your approval. When you need changes, you only need to tell the AI what you want in plain English on that approval email. The AI agent will then search through MJML documentation, if necessary, and find the relevant components and implement your required changes. Then, when you're ready, it will also upload that code into GitHub, making your life like 100 times easier.
Okay, so let's begin. This workflow has two parts. The first one, which we can go over quickly, starts with a manual click to trigger. And then it makes a simple GET request to the MJML documentation source. We're doing this initially to gather the foundational knowledge our AI will need later. Then we extract the relevant content from the documentation using this extract HTML node, looking for a specific CSS selector of .content. This targets the main body of the documentation, ensuring we avoid unnecessary navigation or header elements. You see, the resulting data is much cleaner and focused than the raw HTML we started with. Then we use the Edit Fields node to set our namespace and neatly package the extracted documentation data. This structured data is essential for the next step, where we use the Pinecone node to ingest this processed documentation into our vector store on an index of our choice, in this case, the test index. This vector store acts as a searchable knowledge base for our AI. On this crucial step, we first use a recursive splitter to intelligently break the extensive documentation into smaller, manageable chunks. This helps the AI process and retrieve specific pieces of information more effectively. Then, we embed each of these text chunks using a powerful embedding model. This converts the text into numerical vectors, capturing their semantic meaning. Finally, we ingest these embedded chunks, the vectors, along with their corresponding original text, into the specified Pinecone index, making the documentation queryable by our AI agent in the second part of the workflow. The second part, though, is where the real sauce is, focusing on automating the creation of email templates from images. The workflow triggers off a Google Drive trigger. We set the pull time to every minute because we want it to be near real time. As soon as an image is dropped into our designated folder, the workflow should kick off. We specifically select trigger on changes involving a specific folder and choose the exact Google Drive folder that we've set up to receive our images or email designs or mockups. Then we configure to watch for file created events. Once a file triggers a workflow, the first action is to actually download this file that triggered our workflow to run. And we're going to be able to do that by using the unique ID that we get from the data flow on that initial trigger node. This ensures we're always working with the correct newly added image. And then, because we need to send this image data back to an API, we convert it into a base64 string using this extract node. This is a standard way to encode binary data like images into a text format that can easily be transmitted. Then, instead of using a standard AI agent node directly, we need to make a custom API request specifically to GPT-4.1 with vision capabilities. Why? Because as sad as it is, at the moment, simply selecting the GPT-4.1 model on the standard AI agent node in this platform won't allow the agent to actually analyze and understand the content of an image input. The custom API call is necessary to leverage GPT-4.1's multimodal abilities. It is inherently trained with knowledge about things like MJML, but you have to be very precise and clear with your prompt to get the specific MJML output you need based on the image analysis. You can definitely work off the one that I'm sharing for this workflow as a strong starting point. After GPT-4.1 analyzes the image and generates the initial MJML code for us, we then move on to the MJML API request node. This is where we take the MJML generated by the AI and convert it into standard HTML code that web browsers and email clients can understand. Are you potentially wondering at this point, why not then just ask the AI to generate the HTML for us, instead of going through this intermediate MJML step and then converting it? Well, there are two significant reasons for that approach. Firstly, MJML is much more streamlined, readable, and easier in its syntax compared to raw HTML. They act as pre-built, responsive building blocks, making it less likely for the AI to introduce errors or rendering issues. Secondly, and quite frankly, generating raw production-ready HTML for a full email layout takes significantly more processing and does more tokens from the AI model. Using MJML as a supplementing step substantially reduces the token usage, which means less money spent on API calls. Now, off of that HTML that was sent back to us from the API, we're going to send out a test email to our own email inbox. In this case, Gmail. This is a crucial step so we can actually see what the generated email looks like in a real email client environment. This is also the point in a production workflow where you could actually send the HTML to a dedicated email testing platform like Litmus or Email-Acid. Such services provide previews for dozens of different email clients and devices, ensuring that your email looks great everywhere. But for the purpose of demonstrating the core loop today, we're just going to send it back to my inbox to quickly check to render it. And then, following the test email, using the send and wait for response Gmail node, it's going to send an approval message directly to my inbox as well. This node effectively pauses the workflow, waiting for my input. Once I click on the respond button within that approval email, it presents me with options to either approve the generated email and its code, or reject it and provide some feedback on what needs to be changed. The if node immediately following that Gmail response node then evaluates the outcome, specifically if it's passed my assessment or not. If I chose to reject it and provided feedback, which is the path we're going to go through in this particular demonstration case to show the revision loop, then the workflow proceeds to the AI agent node for refinement. On this AI agent node, I'm giving it several powerful tools to help it revise the MJML effectively. I'm giving it the brain, which is the model, the memory, the brand new Think tool, which n8n just released and promises to significantly improve the agent's reasoning and output quality, and critically, we connect the Pinecone vector database that we configured in part 1 of the workflow. This allows the agent to reference the official MJML documentation if it needs to look up syntax or best practices. On the main configuration of the agent node itself, I'm going to select the tools agent type, indicating it should use the tools we've provided, and give it some specific prompts to guide its behavior. The user message input to the agent is going to be the feedback I provided via the Gmail approval step, the specific changes I want made to the MJML. This is key because, again, we want the AI to modify the structured MJML, not try and edit the raw HTML, which is far more error-prone. Then the system message is the core prompt for the AI that defines its persona and role. In this case, defining as an expert MJML email template development assistant. I also define some explicit rules here for how it should operate and what its output should be, so feel free to leverage and adopt the system prompt for your own needs. Then, just like before, after the initial generation, once the AI agent provides the revised MJML code based on the feedback, it goes through the MJML API request again for conversion into HTML. This ensures, again, that we always have the latest HTML version that corresponds to the revised MJML. And the workflow sends another test email into our inbox with the updated HTML, followed by, again, yet another approval email for that new revised email version. This loop can continue until the design is good enough. Now, if and when we approve this final code after the revisions, it's going to upload both the finished MJML and the corresponding HTML files into specified GitHub repository. From there, you or your team can continue your development work, integrate it into your email sending platform, or manage it like any other code base, benefiting from version control. And that's it, leaving you with some HTML code that is ensured to work. Now, just as a crucial disclaimer, this workflow is not designed to entirely replace skilled email developers. Their expertise in complex layouts, edge cases, and rendering quirks across countless clients is invaluable. Instead, this workflow is intended to give them a significant head start by automating the initial coding from a visual input and handling the basic revisions. Or in the case where you don't currently have access to a dedicated email developer, but you want to try making custom responsive emails from a design, You can leverage this workflow as a powerful tool to get you most of the way there. You can also customize the prompts and steps, such as fine-tuning the GPT-4.1 model with your own email designs to potentially handle different types of design inputs, or increase its conversion capabilities to greater degrees and integrate with other services. And that's really the end. If you made it this far, thank you so much for watching, and please consider liking the video or subscribing to my channel. Let me know in the comments what you want to see next. Have a good one.